Hello, so nice to see you and welcome again to our topical solution series for IGCSE at Maths 0606. Now the topic we're going to look at in this video is on factors and polynomials. The question we're going to solve is winter 2010 or October, November 2010. The paper is 2-1. We're going to draw one question from there on this topic. Let's go on to the question. It is at question number 2. Let's read the question. The expression x cubed plus ax squared minus 15x plus b has a factor x minus 2 and leaves a remainder of 75 when divided by x plus 3. Find the value of a and of b. Now, in this topic, we only have two key things to master. The first one is called factor theorem. The second one is called remainder theorem. Well, what does each of them means? Being factor theorem just tells us that given to us a factor, for this case, for example, x minus 2 is a factor to the cubic expression, we will know that by dividing the cubic expression with x minus 2, you're going to have no remainder at all. And the factor theorem just simply tells us from the factor, in this case, x minus 2, you can draw out its root then to get x equals to 2. And when you substitute the x value into the cubic expression on each of their x position, you're going to obtain an equal 0 equation. Okay, and that is what factor theorem is about. Now, remainder theorem, it just simply means that when you have a divisor, and divisor again will be a binomial, it can be an x minus 1 or 2x plus 1, whatever, it is always in binomial. And then from the divisor, you draw out the x value, and the x value always has opposite signs with the divisor or the factor. You're going to see that interesting relationship shortly. And then by substituting the x value into the x places respectively, you're going to equal its remainder. And that is what remainder theorem is about. Now we're going to use that information. We're going to deal with this question accordingly. Let's go. Now, based on the statement given to us, a factor. Well, this polynomial has a factor x minus 2. Therefore, I put out here x minus 2 is the factor. That's where we draw out the x value. Notice that it has opposite sign, so x equals to 2. Substituting the x equals to 2, the value respectively into the polynomial, then you got that as 2 cubed plus a 2 squared minus 15 times 2 plus b equal to 0. This is the beauty of factor theorem. Now, once you simplify this and go on, gather the like term, then you conclude with one of the equation that you get for yourself, 4a plus b equals to 22. When you notice that you can put the equation in this format, or you can put it in this format. Well, as for me, I usually prefer to have all the unknowns on the left-hand side of the equation and with a constant on the right-hand side of the equation. And we are going to use this later in the process of the simultaneous equation to get our assignment done, getting the value of a and b. And therefore now we're going to go on with the second statement given to us. Then you notice that when a polynomial is divided by x plus 3, you're going to give a remainder of 75. So there we're going to invoke remainder theorem. Now here we go, the divisor x plus 3, we draw out this value, x equals minus 3. we do the substituting of the x value accordingly into the polynomial. Yes, then we get negative 3 cubed plus a multiply negative 3 square minus 15 multiply negative 3 plus b. Then this is the beauty of the remainder theorem, that you equal it to 75 because that is the remainder that it has. Okay, now what we do is we just simplify and then gather the like term, and that's give us 9a plus b equals to 57. Again, this is just a habit that I prefer to put all the unknowns on the left hand side and the constant on the right hand side. Of course, you can leave it as the manner of the one that you like. All right, but as long as you're going to form two equations, and that's where you come to the step when we're going to utilize both of this equation and solving it in a simultaneous equation manner and to arrive at our answer. Now, what I've done here is I'll just take this down and then take this down, which is to make it easier or clearer for our learning. Okay, from here onward, the solving of the simultaneous equation, you can pick and use your whichever method that is confident and comfortable for you. Well, for me, okay, this is what I've done. I noticed that the b's have the same coefficient. Therefore, I've chosen to take the equation 2 minus equation 1. Well, because the simple reason is because I do not want to have a negative 5 here. So that's why I take a 9a minus 4a, and that gives me the 5a, and that 57 minus 22, that gives us 35, and divide 5 both sides and just conclude for us a equals 7. Then we're going to move on using the a value substituted into any one of the equation. Well, here I randomly will just pick equation 1. It doesn't matter which one because you're going to arrive at the same answer. So what I'm going to do, I just substitute a value here. Well, 4a plus b equals to 22. Again, simplify, minus 28 both sides, and that it gives me b equals to 22 minus 28. Yes, clearly you have also obtained the answer for b value as negative 6. And then with that, we have concluded and successfully accomplished the assignment given to us. Find the value of a and of b, and that we showed it here. A as positive 7, b as negative 6, and that's all. And you have successfully run through the whole process of the solution, and 5 marks is securely obtained by you and all of us. Congratulations. And then before we part, and looking forward to see you in the next video. And until then, as I always love to wish you happy learning always. Bye-bye.